In this video, we are going to find the derivatives of trigonometric functions. These are the basics that we should learn. First, let's take note that the derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of tangent x is secant squared x. The derivative of cotangent x is negative cosecant squared x. The derivative of secant x is secant x times tangent x. And the derivative of cosecant x equals negative cosecant x times cotangent x. So example number 1. Y equals secant 3x. So we are going to find the derivative of secant 3x. We know that the derivative of secant x is secant x times tangent x. How about the derivative of secant 3x? So the derivative of secant 3x is secant 3x times tangent 3x. And by chain rule, we are going to find the derivative of 3x. And the derivative of 3x is 3. So therefore, the derivative of y equals secant 3x is 3 secant 3x times tangent 3x. Example number 2. Y equals tangent cube x. So here we are going to find the derivative of tangent cube x. We know that the derivative of tangent x is secant squared x. And how are we going to deal with the exponent 3? So take note that tangent cube x can be written as the quantity tan x cubed. So by power rule, we have the derivative of x to the power of n equals n times x to the power of n minus 1. So treating tangent x as x, we will get this. So 3 tangent x squared times the derivative of tan x. And we know that the derivative of tan x is secant squared x. So therefore we have 3 tan squared x times secant squared x as the derivative of tangent cube x. Example number 3, we have another notation here. F of x equals sine to the power of 4 2x. So we know that the derivative of sine x is cosine x. And how are we going to deal with this exponent 4 and the coefficient of x, which is 2? Take note that sine to the power of 4 2x can be written as the quantity sine 2x to the power of 4. And by the power rule, the derivative of x to the n equals n times x to the power of n minus 1. Applying the power rule, we have 4, which is our n, so we write it up front. So we have 4 sine 2x to the power of 3, that's n minus 1, that's 4 minus 1. And then we are going to find the derivative of sine 2x. And the derivative of sine x is cosine x. So that means the derivative of sine 2x is cosine 2x. But we still have to find the derivative of 2x by chain rule. And we know that the derivative of 2x is just 2. And we have 4 sine cube 2x times cosine 2x times 2. And we can multiply this 2 here to this 4 up front. So our final answer is 8 sine to the power of 3 2x cosine 2x. Example number 4. Find the derivative of f of x equals cosine 3x squared. So we know that the derivative of cosine x is negative sine x, how are we going to deal with 3x squared? So we just have to find the derivative of cosine 3x squared, which is negative sine 3x squared, times the derivative of 3x squared by chain rule. And the derivative of 3x squared is 6x. So that's why we have negative sine 3x squared times 6x. And we can just write this 6x up front. So we have the derivative of cosine 3x squared is negative 6x sine 3x squared. Example number 5. Find the derivative of f of x equals cotangent x times cosine x. We are going to let the first factor as u and the second factor as v. So our formula for the derivative of a product is the first function times the derivative of the second plus the second function times the derivative of the first. So we know that the derivative of cotangent x equals negative cosecant squared x, and the derivative of cosine x is negative sine x. So we are going to follow this formula. So our u is cotangent x, and then the derivative of our v, which is cosine x, is negative sine x, then plus our v here is cosine x times the derivative of u, which is cotangent x, and its derivative is negative cosecant squared x. So we have this. So cotangent x times negative sine x plus cosine x times negative cosecant squared x. And we know that this cotangent x can be written as cosine x over sine x. So we can simplify this part by canceling out sine x. So we have negative cosine x minus cosine x times cosecant squared x. This could be our answer, but in calculus we always write our answer in factored form. We have negative cosecant x on our first term and also negative cosecant x on our second term. So that gives us negative cosecant x times the quantity 1 plus cosecant squared x. So this is our answer. Example number 6. So this is finding the derivative of a quotient. So we let tan x to be our u and cosine x minus 1 as our v. And our formula for the derivative of a quotient is v times the derivative of u minus u times the derivative of v all over v squared. So the derivative of tan x is secant squared x, while the derivative of cosine x is negative sine x. So we are going to follow this formula. So v is cosine x minus 1 each here, and the derivative of u, the derivative of tan x, is secant squared x, then minus u, which is tan x, times the derivative of v, the derivative of cosine x is negative sine x, and of course the derivative of negative 1 is 0, all over the square of v. So our v here is cosine x minus 1. So we have cosine x minus 1 quantity squared. So we have secant squared x times cosine x is cosine x secant squared x, and then secant squared x times negative 1 is negative secant squared x, and then we can also multiply negative tan x and negative sine x. That gives us positive sine x tan x, and we will just copy down the denominator cosine x minus 1 quantity squared. And we know that we can simplify cosine x. So that can be written as 1 over secant x. So we can cancel secant x, so we have secant x minus secant squared x plus sine x tan x all over cosine x minus 1 quantity squared. So this is our answer. Thanks for watching, guys. This is Teacher Rejil. Keep safe.